graduate days. But I need to thank all these people, starting especially with my wife Marilyn, who's over here, who saved me from the deep, muddy abyesses of water-lily ponds and cattail marshes. And all the way down to the garden staff at Charles University in Prague, who helped me with a lot of these plants, many people from all around. Historically, this situation is one in which we usually view the vascular tissue in shoots as eusteels. And these eusteels are usually either the single ring of vascular bundles in a dicot or the atactostele of a monocot with its scattered vascular bundles. But what I want to concentrate on today are aquatic plants which have either polystele or monostele, as I'm defining them, differently from a eustele and a atactostele. And the polystele is one in which there's an endodermal layer surrounding each of the vascular bundles in the stem, and a monostele is one in which there's a vascular bundle around all of the vascular tissue, an endodermal layer around all of the vascular tissue in the stem. Okay? And historically, this has been important and covered a lot, but not recently. And in fact, Beck et al. And then Schmidt dismissed the importance of the endodermis in the 1980s, based upon some of the earlier work. Now, I've gone back and looked at things, and I want to start you on a trail through the basal angiosperms. So in effect, I want to start my punchline first, because here's where it starts. Even though I'm not doing umbrella or any woody things, and I'm just going to stick to aquatic and wetland herbaceous kinds of plants. If we start with Trithuria, and this is one of the 2 specimens, or 3 specimens I do not get from fresh material. I had to get this from material that was sent to me in 70% ethanol. And in Trithuria we find a monostele. Very simple monostele, very little vascular tissue in the center of it, a few xylem elements surrounded intermittently with some phloem, which is not shown here. But there's clearly an endodermis with Casparian bands surrounding this. Now, one of the most interesting things is I've also detected the possibility of supralamellae in this endodermis. Now, this is a story not told yet because I'm not sure about this at this point. Now, let's go on to the next group of basal angiosperms in these nymphaeales, that is the Kabamba group. And in Kabamba and in Brassinia, we always find 2 bundles in the inner node. The nodes are a little bit more complex, but each of these bundles is surrounded by an endodermis. And you can see that here, even though they're not labeled, with the little thin Casparian bands around them. This is normal for these plants. And so we have here at the basal angiosperms, minus amborella, okay, plants that have either a monostele or the simplest of polysteles in them. Now, if we go on into the Nymphia group, we find a mixed bag. In Nufar, we find a polystele present in the stems. Now, these stems in this group get quite a bit bigger in the water, in the substrate, or just along the surface of the substrate. And in Nufar, you can find them, and I hope you can see them here. Would you, somebody turn down the lights for me, please? When you're looking at Casparian bands with epifluorescence and stuff, they don't show up very well in the light. And I like being in the dark anyway, so. But anyway, you can see them very clearly here, and you can even find them into the pedicule. Now, in Nymphia, however, we rarely find them. You can find a central cylinder or scattered vascular bundles in Nymphia, and some of them are associated with axial features of the shoot and leaves. Some of them are associated with roots. Okay? However, going a little bit further in some of this, I have now started finding them in Nymphia thermarum. But they may be associated with root traces, not the vascular tissue of the stem itself. Now I'm going to quickly go through some of the other things here. In the magnoliids, I've only worked on 2 that I could call truly wetland plants, and they're in the Saururaceae, Petunia and Cerulus. And Petunia is in the purple in the background, and you can almost see in that bright field image that there's an endodermis surrounding those vascular bundles. It's harder to see in Cerulus, but if we take a look at this under epifluorescence with staining, usually a Bergman stain, counter stain, or something else, You can see even under low power, there's a nice endodermis here, and in higher magnification, this endodermis shows it pretty well with Casparian bands that occupy a good section of the radial walls of these endodermal cells. In Cerurus, it's a little bit harder to see. I can't actually see these very well under very low power, even under fluorescence. But as you go up in magnification, you can see this undulating endodermis surrounding the vascular bundles all the way around the full axis. So it's a monostele. So both of these are monosteles. Okay. Now let's go on into the monocots quickly. A lot of the monocots I'll cover have central cylinders in them, as we usually refer to them as stems, surrounded by either sclerenchyma layer or, as in this case, an endodermis. There are vascular bundles also out in the cortex, but most of the vascular bundles are in what we would call the central cylinder. Okay. Here, you can see very clearly in the inset over to the right, there's an endodermis with nice Casparian bands, and you can also see that in the vascular bundles that are in the cortex, there's also an endodermis around each one of them usually. And this does not necessarily go very far out into the sheathy leaf base, as you can see here. These vascular bundles in the leaves have sclerenchyma around them, fibers around them, and not an endodermis. Okay. I'm going to take you through the other major families of the monocots that have wetland plants that I've been able to get. And let's start with Araceae. This is going to be hard to see here. I looked at this earlier and I couldn't see these endodermal Casparian bands in this. But in Aurantium, for example, and in Peltandra, we can find an endodermis. It's really hard to see in Aurantium, but there are Casparian bands going down in through here someplace. Okay. But I didn't have apparently a very good specimen on this. Now, the literature is full of things, especially in various anatomies, dicots and monocots, of an endodermis present or an endodermoid layer or a starch sheath or things like that in these various groups. What I'm trying to do is to see if this is actually there or not in all these different groups, especially in the wetland plants. I'm not, as I said earlier, I'm not going to concentrate at all on woody species. Okay. It's easy to see this in some other of the Elismatales. Nias is sort of neat because it looks like a root. And for all practical purposes, it looks like a root and is a root, but it does have roots which do have the same kind of structure to them. Okay. Hydroclase is one that was not supposed to have an endodermis in it, but I have detected endodermal Casparian bands right through there. And they don't show up very well, but they're there. They're very thin. They're a little bit thinner than the others, although not necessarily shorter along the radial walls. Now, in the Aspergillales, I'm including a couple of things in here that are not normally wetland plants, because in our driveway, along our driveway outside of Oswego, New York, this spring and last spring and the spring before that have been very wet. And when they get wet like that, convallaria and podophyllum and things like that grow in saturated soil, and for all practical purposes, they're like wetland plants. So I've included that in there. Iris pseudochorus has an endodermis surrounding the central cylinder. And all of these others, including into the poales, have endodermis, except for most of the grasses that grow in wetland environments. And most of these that we have here, one of them comes from upstate New York, but the others are all from China, in the Yangtze River, Jinghan floodplain. Okay. There, you instead find a sclerenchyma ring, and only in Phalaris do we find something that has an endodermis associated with it, okay, in the stem. Now, I'm not going up into the culms and things like that, because culms usually lack such an endodermal layer to them. Now, let's finish off the monocots with something from the Comelananes and the Zingiberales. And here again, once again, I wasn't expecting to find anything, an endodermal layer in these, but as I looked closely and stained them in different ways, I found a nice little endodermis in Pontideria and in Canna, which stands out more clearly, and even in Thalia, which I did not expect at all. These are generally monostelic in nature, except for that. Now, let's go to the dicots, eudicots. Here is the big problem. Most of the literature had ceratophyllum at the base of the eudicots with an endodermis. Other people have reported there's an endodermis. Others said there's an endodermoid layer there. Okay? I and my colleagues in Prague, both here and there, have done dozens of specimens presence of this, both low and high on the axis of these plants, and we've never been able to detect an endodermis. I've used many different kinds of staining techniques, and I've included also acid digestion, where the epidermis will resist acid digestion because it turns out to have a suberized cuticle to it. But there's no endodermis in this whatsoever that we can detect. Period. You can see some of the different staining techniques that I've used here. Now, let's go on to the ranunculales and then the proteases. In ranunculus, I didn't know what to expect. I found it only in ranunculus repens. I haven't found it in the other two species that we found in wetlands, Lamula and Lingula. And in contrast, in the Berberidaceae, Polystely and Caulophyllum do not have an endodermis in them, even when they're growing in our driveway in basically wetland conditions. It's just a typical eustele. But this is a polystele in this one ranunculus, which is not what I had anticipated at all. Now, Nelumbo. Nelumbo, of course, is a very well-known aquatic plant, and it's very famous in China in particular. And so I've gathered some, both Lutea and Nucifera, and at first I was looking mostly at the swollen rhizomes, because that's what we're most familiar with, and I used to use them in my plants in society class. Used to cut them up and cook them. And in that, there's nothing like an endodermal layer around any of those scattered vascular bundles. And then when I went into the piece of the rhizome, right near that, there was nothing. That's up in there. But then when I've gone further out into what I would now call stolon, because it's actually above the substrate, that little image down there on the next to lower left. So it's only in that one little, apparently that part of the stolon. Now let's go to some others. Let's go to the base of the core eudicons with Gunnera. And Gunnera is sort of neat. This is another specimen that I didn't get fresh. I could only obtain this from herbarium materials, thanks to Flusibona. And that is a monostele. Neat little endodermis. All of the Gunneras have an endodermis around their vascular tissue in the stem. But whether they're monosteles or polysteles, and here is polysteles. If I gave you this in an exam in a botany class, in an advanced botany class, you might put this down as a fern, or the one down there as a fern. Okay? But they also extend into the petioles, where even if they're monostelic, they become polystelic, if you will, because each bundle is one. But just this year, we found that the endodermis extends into the veins, the leaves, the leaf blades of this. And this, by the way, is whether these are grown in wetland conditions or in terrestrial conditions. Now, I wanted to work on a lichen, and so I got hold of the Tunia aquatica. And as soon as I looked at it, I said, good, it has an endodermis in it. Now, as I started examining it with epifluorescent techniques and acid digestion and other things, I've not been able to demonstrate this ring of cells around there is an endodermis with Casparian bands. It has suberin in it, and it has lignin in it. And so it has suberin lamellae and a little secondary wall in it, but I've not been able to demonstrate Casparian bands in it yet. And I'm going to go through some others here. Myriaphyllum, all the way up into the leaves. So we have a monostele, and we find this endodermis all the way into the leaves. In Trepinatans, which I just published on, along with another one coming up in a few minutes here, we have endodermis around all parts of the axes, from the lowest part of the stolon, where it would be hypocotylar, all the way up to the peduncular pedestal. To Ludwigia, we have a monostele. To Brassica roripa, when it grows under wetland conditions, it has an endodermis surrounding those, all the vascular bundles. To Amaranth with Alternanthera, there's an endodermis. I've not been able to demonstrate it adequately in any of the Drosseras. But of course, earlier, over a decade ago, I couldn't find a ringula in any of the Drosseras. Then in plants like Lysomachia, Myosotis, Bacopa, and Mentha, they all have an endodermis around their vascular tissue, all being a monostele. Then in Hipparus, Hipparus is well known for having a monostele, but then we found it both below water levels, as in the central picture, above water levels, and then into the leaves. And you can see this leaf over here, all the way up in there. You can see the individual vascular bundles around the veins, individual veins. And then in Justitia, that's a polystele there, which also extends up into the leaves, but not into the higher reaches of the stem that's well above water. And in the Asterales, then of course you might expect it in the Menianthaceae with Amphoides and Menianthes, but they go all the way into the petiole. It's a monostele in the stem, but it becomes each bundle surrounded by an endodermis in the petioles, even into the leaves. In Artemisia, I'm just working on this with my Chinese colleagues, we found in the 2 species of Artemisia that grow in the Yangtze floodplain, we found a nice endodermis surrounding the whole of the vascular tissue there. And then finally, in Hydrocotyle, Hydrocotyle starts off as a monostele, and then when you go into the petioles, each of the veins or vascular bundles of a petiole becomes surrounded by an endodermis. And so I'm turning it polystely. And that's sort of neat in there because it also goes into the leaves. Now, finally, I'm doing this through the whole of the angiosperms if I can, and I'm doing as many as I can. This, you can see the kind of pattern we get, the distribution we get from the basal angiosperms, magnoliads, through the monocots, and the eudicots. In other words, there's an endodermis in almost all of these plants that I've looked at so far, and it's also there in the literature. And when the literature does not have an endodermal layer present in these aquatic or wetland plants, and I look at them closely, I'm tending to find them there, except for water. And I'm not working with just monocots, I also do a few ferns. But anyway, I think Beck and et al. Were not necessarily correct, because you find this endodermis surrounding the vascular tissue in the most basal of the basal angiosperm.